All right, this should be the last video for section 8.1. So this is just a couple special cases when we're dealing with systems of linear equations in two variables. So the ones we've seen so far have been designed to get us not just an answer, but also a nice answer, some sort of whole number answer. In general, if you kind of just pick numbers out of a hat with these types of problems, if for some reason you're trying to make your own examples or practice problems, most of the time you can still solve them. You're just going to get fraction answers like a lot of the time. You really kind of need to sort of plot things out a little bit to hit some of these nicer whole number answers. That said, the other thing that can happen that is a little bit funky is sometimes you can get a no solution type answer, or you can get the sort of opposite end of the spectrum, which is sort of an infinite number of solutions. So rather than getting just one pair of numbers x, y that works, you can get no pair will work, or you can get sort of an infinite number of pairs that work. So let's check out both of those special cases just so you know what to expect if that happens and what it's going to look like. Let's start with, so x plus 2y is 9, and 2x plus 4y is -6. You could do either technique here. You could do a substitution where you maybe take the top equation and you solve it for the x. X would be, -2y plus 9. That works. I'm going to set this up as an elimination / addition method because what sticks out to me is, maybe if I multiply the top by -2, I could get -2x and +2x, right? So let's do the top times -2. So -2 times x plus 2y equals 9 would be -2x minus 4y equals -18, right? So just multiplying everything in that top equation by -2, -2x, -4y, -18 equals, right? We're just going to rewrite the second equation underneath, 2x plus 4y equals -6, and so then I'll just add them up. And lo and behold, so what happens on purpose, I was trying to cancel, right, the x values. So -2x plus 2x is 0. So those are done. But as an unforeseen consequence, the y values also cancel out, right? So this is sort of -4y plus 4y also wipes down to 0. So both of my variables are gone. That's maybe not quite what we were after, right? What's going to happen over here is then, so this is just 0 on the left. All the x's and the y's are both gone. On the right-hand side, I've got -18, plus a -6 would be -24. So if I kind of take those two together, I'm getting this impossible equation. 0 equals -24, right? That's an impossible scenario, what we would sort of think of as an inconsistent equation, right? We've sort of had this happen to us before. I think just solving regular linear equations, every now and then we would get a situation that was sort of an impossible scenario. And so what that means for us is not really anything more dramatic than there just is no solution. Essentially what that means is the original versions of these two equations are almost the same, but they're out of sync as far as the constant terms go. If you kind of look back at where we started, you can see pretty quickly, right, this is sort of, x plus 2y and then 2x plus 4y. The bottom version of this is really just a doubled version of what's up top, except on the right-hand side where it's 9 versus -6. If it was 9 on top and it was 18 on the bottom, then they would just be two versions of the same equation, and we'd get a little bit of a different scenario. In this case, however, right, they don't sync up. They're not really sort of coming together in the way that we would want. But that's fine. It just means that it doesn't work. In some sense, maybe that's good news because we just sort of bail out early. We just say, okay, well, fair is fair. It's not going to work. So we'll just call it, can't fight City Hall. So we'll just say this is impossible. It's an inconsistent equation. So our answer here is no solution. If we did another example, let's say, right, 4x minus 2y equals 2, and then 2x minus y equals 1. Another system to work with. Let's do a substitution here. Let's maybe solve for this y in the second equation. at this point, and in some sense in the homework, tests, and quizzes, I'm not really particular about which solution type we're using. I kind of think either of these methods is fine. I would say just use whichever one. It seems to be easier on a per problem basis. This one we have just the sort of y sitting here. So let's solve for it. You could make an argument, hey, what if I just multiply this one by -2? Wouldn't that also sync everything up? And it's like, yeah, that's true, I understand, but I wanted to change it up. So let's solve the second equation for the y value. So 2x minus y is 1. If we just do a minus 2x from both sides, that's going to tell me, right, in purple, right, negative y would equal minus 2x plus 1. We had this happen before in a substitution, right? We had sort of a negative value equals. So we just divide by -1. You could also think of it as multiplying by -1. Flip all of our signs around, sort of plus minus, flip them all around. So the y value here, a positive y value, would equal 2x minus 1. Don't try to fool around. I mean, you could do something and try to be clever where you're saying, well, this is a minus 2y and this is a minus y. So if I just sort of sub this in as it is, doesn't the minus kind of come in for the minus? And like, I don't know, you can kind of do that, but like, let's not make it more complicated than it needs to be. You're going to be better off just trying to sub in for a positive y and don't try to do anything too fancy. It's like trying to juggle and ride a unicycle at the same time. Yeah, just do one or the other. You don't need to do them both. I sound extremely judgmental right now, but let's not get carried away. We're all just sitting at home right now. So let's sub this into, so our substitution, right? We got this from the second equation. Let's sub this back into the first equation. So 4x minus 2y equals 2. So the y value here is 2x minus 1. So we're subbing it in for the y. Boy, that didn't work very well. Into the y in the second equation. So 4x minus 2 times, right, the substitution, 2x minus 1 equals 2. If I distribute, right, that's going to be minus 4x and then plus 2, right? So 4x in front minus 4x plus 2 is 2. You can probably start to anticipate what's about to happen. Well, 4x minus 4x is 0, and then I have, right, 2 on the left and 2 on the right. Well, my x is canceled out, right? So this is another one of these equations, right, where the sort of, in doing a substitution, in this case, the variables also canceled out in the same way that they kind of canceled out in the one up top. So the special cases are happening when we do either an elimination or a substitution, and either and all of the x's and y's are getting canceled out, kind of regardless, right? We're just sort of, the variables are dropping like flies. They're just out of here. And it depends what we're left with. In this case, what we're left with is the sort of identity equation, this sort of simple equation, 2 equals 2. That's always true. So rather than, right, the one we had before, which was the never true, 0 equals -24, this version of the equation gets us 2 equals 2, which would always be true. You could also get a version of this that says, 0 equals 0, right? Something that's always going to be true. And so what that means for us is you're going to get an infinite number of solutions. Now, technically, that doesn't mean every single number pair works as a solution. In theory, right, your sort of solution here is an infinite number of pairs in a particular form. You can kind of write it a little bit based on the stuff. What I care about personally is just that you're sort of marking it as infinite solutions. I'm not really looking for the setup of what does the particular pair need to look like. If we just say that it has infinite solutions, that's kind of good enough for me for now, and we can sort of move it along. So it's a couple special cases. That's sort of, in some sense, what can go wrong, what might be unexpected when you're sort of solving these problems. If you're not getting one of those two cases, you should be able to just get a solution pair, an x and a y value that sort of work together and make everything true. If somehow you discover some sort of fourth option, if you sort of break into some sort of extra dimensional solution and you're looking through time and space, and you find some sort of fourth solution possibility, hey, let me know. That sounds pretty cool and pretty interesting, and let me know. Maybe you can be the teacher now. Who's to say? Anyway, that's the end of 8.1. All of our systems of linear equations in two variables.